Hello everyone and welcome to this new session. Today I'm going to focus on how to measure horizontal angle and distance using total station. And the method for measuring horizontal angle is the same using total station or even Theodolite. So you can apply the same method to measure a horizontal angle to a very high level of accuracy using Theodolite as well. So let's get started. To simplify the principle of measuring horizontal angle using total station, it is very similar to measuring a horizontal angle using this circular protractor. In fact, let's say that you've been asked to measure a horizontal angle between these two directions here. You know that angles are measured usually using degrees. So this is 0 degree here, and here we have 90 degrees. Here we have 180 degrees, and here we have 270 degrees. And then when we return to the first point that we started from, it would be 360 degrees, which is a full circle now. So to measure this horizontal angle, in this case, between these two directions, if you look here guys, this is 0, here we have 10, 20, 30, 40, 50, 60 here. So we have 60 degrees here, 90 degrees here. So it would be very simple to say, okay, this angle, let's call it alpha, which is 90 degrees minus 60 degrees, and the answer would be 30 degrees. This is the horizontal angle between these two directions, in this case using a circular protractor. And this simple principle is exploited in theodolites and total stations to help us to measure horizontal angles in our projects. So if you have a look here guys, we have here like very old theodolite. As you can see here, this is more than 200 years old, in fact, this one. So this is the horizontal plate for measuring the horizontal angles. As you can see here, this is the circle. It's very similar to the principle of the circular protractor. Okay, and then the operator will cite the first direction, and then like here for example, and then will turn to the second direction, and then to measure the horizontal angle. And now we have more advanced instruments like this theodolite for example, and this total station. They apply the same principle for measuring horizontal angles, but for a better or for a higher level of accuracy. So instead of saying, okay, the angle is 30 degrees, now we are going to measure the angle to a second or even sub-second accuracy. So here for example, this theodolite have something inside to measure the horizontal angles, and for the total station the same principle. So theodolites and total stations apply this principle to measure the horizontal angle between any two directions to a very high level of accuracy, to a second accuracy or even sub-second accuracy. To let you understand the accuracy of the readings using total station, let me just clean everything here. So the accuracy of the readings guys using total station, as you know here, okay, we know that this is 0 degree, and here we have 1, 2, 3, 4, 5, 6, etc. Now let me take just 1 degree from here guys, just 1 degree, one slice. Okay, imagine that we have sliced this circle into 360 degrees, 360 slices, and then I will take just this one, the first one here. I will draw it here. For example, it would be something like that. Okay, it would be something like that guys. So here we have this arc of the circle, which is 1 degree. Now let's divide this 1 degree into 60 minutes, 1, 2, 3, 4, 5, 6, etc. into 60 minutes. Okay, so each one of these 1 minute. And again, let's take just the first minute, one slice from here to here. I'll take this slice here, and then I will repeat the same thing. So now again I will divide this 1 minute into, and now I have here 1 minute. I will divide this 1 minute into 60 seconds. Okay, so each one of these 1 second. So this is the level of accuracy that we are measuring our horizontal angles to using total station or even theodolite, okay, which is degree, minute, second. So if you measure any angle, you will write it in this for example 35 degrees, 28 minutes, and then for example 47 seconds. So guys, if you have a decimal degrees number, for example 27.365,103, this is a decimal degree. So to convert this into the format of degree, minute, second, like this one, just using your calculator, just press on this button here, as you can see here in red. So this button will convert the decimal degrees into degree, minute, second, and also will convert the degree, minute, second into decimal degrees. So if you need to convert your angles or to do any calculations using this format of the degrees of the measurement of the angle, you can just press this button on your calculator, this one. And guys, because in surveying we are usually working to a very high level of accuracy, instead of measuring this angle from one direction, for example from left to right, and then saying it is 30 degrees, for example 1 minute and 2 seconds, we are going to measure it from left to right and then from right to left, and then to take the average. For example, we measure this from left to right and then from right to left to be, and then 0 seconds, and then we will take the average. In this case would be 30 degrees, 1 minute and 1 second. This is just an example. So to improve the accuracy of our work, we are going to measure from left to right and then from right to left, and this will help us to reduce the error value because of the distortions in the lenses and a lot of reasons in fact that can affect the accuracy of the reading. To minimize the error value, we are going just to measure the angle from left to right and then from right to left, and then to take the average. So I will start with explaining the method of measuring a horizontal angle, and then we will take two numerical examples to apply this method. Let's say that you've been asked to measure a horizontal angle between two directions or 2 points A and B. What you are going to do is you need to set up your total station over station X, let's call it here. So if you look at this table, we are going to arrange a small table like this, guys. So here in the first column we have the instrument station here, which is in this case station X. So I will write here X. And then the station sighted, I will cite station A. So citing station A means there is a nail here, and then you are going to set up a prism on a tripod over the nail. This is a prism, guys. So you are going to set up a prism here over A and then a prism over B. After you set up your total station over X accurately, it should be absolutely leveled and absolutely centered over the nail. And then you are going to sight station A. Sighting station A means that you need to sight the middle line on the prism, guys, here, this middle line here. Okay, so when you look through the telescope of your total station, this is the telescope of the total station, when you look through here towards A, the center line should be exactly over the center line of the prism. And then you are going to look at the screen of your total station. This is the screen of the total station, guys, here, the same here. So there is something called horizontal angle. In some total stations they will call it HZ or HA. You need to find out what is the term used in your total station, and then you need to write down the value of the horizontal angle here. This is the first measurement that we have collected. So you will cite A, and then you will write down the horizontal angle value, and then you will turn your total station telescope towards B. You will cite the prism over B accurately, and then you will look at the horizontal angle value on the screen of the total station, and then you will write it down here. This is called facelift over B. The first measurement here is facelift over A, and the second measurement facelift over B. Now at this point, guys, you need to flip the telescope. This is the telescope here. This is the telescope. You need to flip the telescope 180 degrees. Okay, and then to rotate horizontally the total station by 180 degrees as well. And then you will recite B accurately, and then you will write down the horizontal angle value here, and this is called the face right over B. So the face right from here, guys, this is face right here, it is over B because we are citing B. Once you've done that, you will turn the total station, return it to A, cite station A accurately, and then collect the reading, the horizontal angle from the screen of the total station, and then write this measurement here. This is the fourth measurement. Now you have done 4 measurements, and you are ready to calculate the mean angle between these two directions A and B. Now before doing the calculations, guys, when you cite station A and station B, you can get the distance as well. For example, in this total station, this is the distance function here. So to get the distance, after you cite the middle point of the prism, you need to press this button in this case for the distance. It's F2 for this total station. It's different from make to make, from total station to other total station. Okay, so just press this, and then you will get a value here for the horizontal distance, and then you will get a value here for the slope distance. So this is horizontal distance, a triangle with a line here. So this is what we are interested in, the horizontal distance in this case. So here we will say, okay, for line XA, we will write down the number here, the horizontal distance that we will get from the screen of the total station from here. And the same when you cite B, you will write down the horizontal distance that you will get. Now for the calculations, to calculate the facelift value, it is simply the second measurement minus the first measurement. So here, which is the facelift over B, this one, minus the facelift over A, this one. Now to calculate the face right, which is the third measurement minus fourth measurement, the face right over B minus the face right over A. Okay, now you have here two values. They should be very close to each other. The difference between them mostly would be in seconds. The final mean angle, which is our aim, which is the average of these two numbers. So here we will have a number here plus this one divided by 2. Okay, I will write it in this way. Let's say face left plus face right divided by 2, and this is the mean angle, and this is the horizontal angle between these two directions. Okay, so now let me clean everything, and then let me summarize the whole process in a very simple way, guys. Your total station is over X. You need to calculate the horizontal angle between A and B. You will cite station A, and then you will write down the horizontal angle value here. This is the first measurement. And then you will cite station B. You will write the facelift over B here. This is the second measurement. And then at this point, you're citing B now. You are going to flip the telescope of the total station by 180 degrees, and then you are going to rotate the total station horizontally by 180 degrees. And then resight station B, and this is called face right over B. This is the third measurement. Write it down here. And then return to point A, sight A accurately, and then write down the horizontal angle value here. And this is the fourth measurement. Now you've done the measurements. At some point when you are sighting A and B, just collect the length or the distance, the horizontal distance, by pressing the suitable function. Now the final face left, which is the second minus the first measurement, the final face right, the third minus the fourth measurement, and the mean angle, the final angle, which is face left minus face right, plus face right divided by 2. That's it. Okay, it's very simple and straightforward process. Now let's take this example. We need to measure the horizontal distance between A and B from X. We set up the total station over X. We sighted A. Look at the value of the horizontal angle on the screen of your total station, and then in this case it was 0 degrees 10 minutes and then 8 seconds. I will write it down here. This is the first measurement. Okay, and then I will turn towards B. I will sight the prism over B accurately, and then I will write down the horizontal angle here as a face left over B, and in this case it is 53 degrees 56 minutes and 3 seconds. At this point I'm going to flip the telescope of the total station by 180 degrees and to rotate the total station horizontally by 180 degrees as well, and then to resight station B and to write down the horizontal angle value here. This is the third measurement here, which is 233 degrees 56 minutes and 5 seconds in this case. Finally I will return to sight station A again and to write down the final measurement of the horizontal angle here for face right over A here. It is 180 degrees 10 minutes and 17 seconds in this case. So now I've collected all the measurements required to calculate the final horizontal angle. Okay, so here to calculate the face left, as I have just mentioned, the second minus the first measurement. This is the second measurement, guys, here. This is the first measurement. So the second minus the first measurement, it would be in this case 53 degrees 56 minutes 3 seconds minus 0 degrees 10 minutes 8 seconds. I will calculate that to be 53 45 55 seconds. Okay, now here to calculate the face right, which is the third minus the fourth measurement. This is the third and this is the fourth measurement. So the third minus the fourth. In this case, the face right value is 53, 45 and 48 seconds. So now here, guys, always you need to use your judgment. It is very important to judge your numbers, not just to do the calculations and then write down the numbers without any judgment. So as I mentioned here, these two numbers, guys, should be very close to each other because they represent the same angle, which is this angle. Okay, but all that we have done is just we measured this angle from left to right and then from right to left, and then we are going to take the average. So because of that, they should be very close to each other. As we can see here, the difference between these two numbers is within seconds, a couple of seconds. So 53 here, 53 here, 45 here, 45 here, and then the difference within seconds, which is okay. Okay, this is one way to judge your numbers. And also, if you look here as well, for the face left and the face right over A, face left and face right over A, also these two numbers should be within 180 degrees, plus minus a couple of seconds. And also the difference between the face left over B and the face right over B, these two numbers here should be within 180 degrees plus minus couple of seconds. Okay, so now after you have calculated the face left and face right, and then you judge your numbers and you feel everything is okay, the accuracy is okay within a couple of seconds, you are going to calculate the final mean angle, which is this value plus this value divided by 2, which is the average of these two numbers. I calculated that to be 53 degrees, 45 minutes and 52 seconds. And don't forget, at some point when you are sighting A and B, to collect the distance between X and A and X and B, this distance here XA and this distance here XB, by using the distance function on your total station. So in this case I measured that to be 593.011 meters between X and A and 450 between X and B. These are the distances. Okay guys, now by doing that we have calculated the horizontal angle between these 2 points, which is this one. This is the value, the final value of the horizontal angle, and also we have calculated the distances between our station X and both directions, or both points A and B in this case. Let's take another example. The same process guys. So you will set up your total station over station X, you will sight station A, and then you will write down the face left over A here, here, and this is the value. In this case, after I sighted the prism over A, you will look at the screen of the total station and then you write down the horizontal angle value here. In this case it was 315 degrees, 33 minutes and 56 seconds. And now I will turn the total station to B. I will start the prism over B and then I will write down the horizontal angle here. In this case it is 2 degrees 30 minutes 41 seconds. Now at this point, as I mentioned before, I will flip the telescope of the total station and then I will rotate the total station 180 degrees and then I will resight B, and this is the third measurement. I will write it down here. I will look at the screen of the total station and then I will write down the horizontal angle here. This one, this is the third measurement, and then I will return to A and then I will write down the fourth measurement, which is this one. Okay, now I think you have a good understanding of how to collect these measurements. Now let's do the calculations for this case. Now to do the calculations, first we need to calculate the face left here. As I mentioned before, to calculate the face left, the second measurement minus the first measurement. This is the second measurement here, this is the first measurement. If you look here before we do the calculation guys, 2 degrees minus 315, it would be negative number. So in this case, the second minus the first, it would be negative number, and then we have some issue here that we have to deal with. Let's have a look at this slide here just to explain this case and to let you know how to deal with this kind of numbers. Let's say guys that you have just applied the same process here. We have a station B and then we sighted station A and then we turned to station C. When you sighted station A, the horizontal angle value was 350 degrees and this is the first measurement. And then you turn towards C. In this case, the second measurement, when you looked at the horizontal angle on the screen of the total station, it was 15 for example. But when you apply 15 minus 350, it would be in this case minus 335 degrees. Okay, and it's clear if you look here, this angle is not 300. There is an issue here, and this is because we have passed the 0 point on your total station. So for example, let's look at this circle here. You know that the 0 is here. When you sighted station A here, the horizontal angle value was 350 degrees, and then when you started to move your total station towards C, it started to increase from 350, 351, 52 until you reached here 360. At this point, the horizontal angle value would be 0, and then it will start from 1, 2, 3, 4 until you reach 15 degrees value. So now if you look at this, it is very simple now to calculate the horizontal angle for this case. You will say, okay, from here to here, it is 360 minus 350, it is 10 degrees, and then from 0 to 15, it is 15 degrees, yeah? So it would be in this case 10 plus 15, 25 degrees, the horizontal angle in this case. Okay, so in this case, 15 minus 350, and then the answer would be in this case minus 335 degrees, and then if you add a whole circle 360, you will get the right answer, which is 25 degrees in this case. Okay, now as a rule, guys, I can say once you have got a negative answer here, if you do the second minus the first and then you've got a negative number, just add 360 degrees and then this will adjust your answer. I tried in this slide just to explain why you need to add 360 degrees, and this is why here, because you passed the 0 point, and then because of that you completed a whole circle. Because of that we need to add a whole circle or 360 degrees. So if you do the second measurement minus the first measurement and then the answer is negative, in this case just add 360 degrees. And similar for if you do for the face right, the third measurement minus the fourth measurement, if the answer is negative, just add 360 degrees, and then this will adjust the solution. Okay, now let's return to the example that we started. In this case, as I mentioned, the second measurement minus the first measurement, in this case it would be a negative number. 2 minus 315 would be a negative number. In this case I will add 360 degrees to the answer. And this would be the facelift. I will write it down here. In this case I calculated that number to be 46 degrees 56 minutes and 45 seconds. Now here the face right, the third measurement minus the fourth measurement. This is the third measurement here, guys, and this is the fourth here. So 182 degrees minus 135, etc. It would be in this case positive, so I don't need to add 360 degrees. I will get the answer as it is, and in this case it is 46 degrees 57 and then 6 seconds. Okay, now before I move ahead, I will judge my numbers. As I mentioned, these two numbers should be close to each other. The difference between them should be in seconds. In this case it's about 20 something seconds. So let's go ahead with the calculations to calculate the mean value, the final value, which is in this case 46 degrees 56 minutes and 55.5 seconds, and this is the final mean angle, and this is the value of this angle. And don't forget, if you need the horizontal distances between x and A, x and B, just to press the button to get the distance on the screen of your total station, and then you will write it down here, the distance between x and A, x and B. Okay guys, I hope that was useful today. In today's session you learned how to measure a horizontal angle using total station or even theodolite twice, from left to right and then from right to left, and then how to calculate the final mean angle. So you need to collect 4 measurements: facelift over the first point and then facelift over the second point, face right over the second point and then return to the first point, face right, and then you are going to calculate the final face left, the second measurement minus the first measurement, and the final face right, which is the third measurement minus the fourth measurement. And don't forget, if you have a negative answer, add 360 degrees and then calculate the mean value of the final angle. And if you need the distance, just don't forget to use the function on your total station to get the horizontal distance that you need for your project. Thank you very much for listening and enjoy your time. Bye now.